Okay, now it should be recording. Perfect. Thank you. Okay, so with this question, guys, so I'll get you guys, make sure you mute your mics unless you have questions. Otherwise, I get feedback from you guys. So make sure that you've muted your mic. So for the first question, I'll just do a little quick recap. So in your graphing calculators, you want to graph. In my case, my first question is -9 log of x. You want to go -9 log and then in brackets x. So Ailish, can you mute your mic if you don't mind? Thank you. Yeah, there was just a feedback coming off from that, so that's perfect. Okay, so -9 log x. Use your standard window, and then you want to graph that. Okay, so if you guys look closely, it might look like it touches your y-axis, but it doesn't. Okay, so what I've done is I've sketched that, and now I'm doing my domain. For all logarithmic functions, the ones that you guys are doing in this course, you're going to see that it's going to be x is greater than 0 XER if it's just an equation. So the graph is greater than 0, but it does not touch 0 for x equals 0. So that's your domain. Your range, you'll find that y such that the graph will go downwards forever. If you guys look here, this arrow is showing that it's going down forever and up forever. So you're going to see that the range is YER for all of these graphs that you should have for question number 1. So those are easy marks if you guys remember that. Okay, so domain and range, greater than 0 for x, and then range, YER. The first question, the coordinates of the intercept, they want the x-intercept and the y-intercept. So what you want to say is for the intercepts is that there are no y-intercepts, okay? Or you can say none, because it doesn't touch your y-axis. And then for x-intercept, what you could do is you can go to, if you want to confirm this, you can go second trace, number 2, and then you can go to the left side of that x-intercept, the right side of that x-intercept, and then press enter and enter again. Okay, so second trace 2, left side enter. No, it's not working. Okay, let's try that again. Second trace number 2, left side enter, right bound enter, and enter again. So you guys are pressing enter again, but I don't have to. It says that the x-intercept is 1. Okay, so for all of these, you should actually see that the x-intercept is 1. So I'll prove that in the next question as well. So all you have to do is put 1, but they do want the coordinates. So you do have to put 1, 0 for the x-intercept. Okay, so I'll move that up just for you guys to see. So 1, 0, make sure you include the coordinates like that. And then you just, for the y-intercept, there are no coordinates because there is no y-intercept. Okay, so domain, range, intercepts, you should pretty much have the same answers for all the graphs. And then the end behavior might change though. So I'll show you what the end behavior looks like. When we label quadrants, this is always quadrant number 1. This is quadrant 2. Quadrant number 3, and quadrant number 4 when we label our quadrants. You always want to label your quadrants from where it starts to where it ends. Always go from left to right. So this is the left end, and this is the right end. The left end is starting in quadrant 1. So that's going to be our end behavior. We're going to use that. We're going to say that it goes from quadrant 1 to, the arrow just says that it's going to, where it ends, the right end, ends in quadrant number 4. So that would be the end behavior, and that's how they want you to write it. Okay, so I use Roman numerals, but you could write 1 to 4. I'm not really picky about that. Okay, so that would be your answer that you would include for end behavior. Okay, so that might change depending on each of these graphs, but pretty much this, and this should be the same for all of the graphs. Okay. I'm going to repeat those steps now for question B. Okay, so question B for me is log base 8 of x. So what you really want to just pay attention to is that you know how to put that into your calculator. So let me know in the comments if you guys have an older version style calculator. I do want you to check that you're able to put this in your calculator. So everybody should be pressing alpha window number 5. Okay, so I would have to press y equals though first, right? So I would have to go to y equals to be able to graph it. Once I'm on y1 for y equals, I would clear whatever is there. Okay, so I'm going to go to my calculator to show you. Go to y equals, clear what's there, and in this step, you're going alpha window. In my case, number 5 is the same as yours. Okay, if you have a newer style calculator, and then that first blank is where you're putting that little number. In my case, it's 8. In your case, you have that for the last question where you have a base of 2. And then within the brackets, you're putting the value of x. And then you can keep the standard window that we've had. You shouldn't have to change that for any of the questions. And then you can graph it and it's going to look like this, okay? When you sketch it, you got to watch how you draw these. If you guys look, the x-intercept is still going to be 1. But when I sketch it, it should look like something like this. So it goes through 1, but it shouldn't touch your y-axis like we were saying before. You want to get very close to that y-axis, but not really touch it. Okay, so there's my y-axis. So I'm going to just go close to it and continue downwards, even though your graph on your calculator might look like it stopped somewhere. Yours should actually continue. So don't just stop it there, continue downwards and then put an arrow on each end. So this is what my graph should look like, okay? Now, once you have it sketched, let's do our domain. Domain, same as before, you're going to say x such that x is greater than 0, xer. Okay, so that is not changing. And then our range, same as before, we would say y such that y is an element of the real numbers, same as the previous question as well. Then we have the coordinates of the intercept. We can say that the y-intercept, there is none because it shouldn't touch the y-axis. And then for x-intercept, if you actually found it, it would still be equal to 1. So the coordinates are 1, 0. And then we have the end behavior. So like I said, this one's a little bit different than the previous one. The reason being, this is now your left end. This is the end that's most left on your graph. And this is now your right end. So my left end in this case is actually in quadrant number 4. And my right end is in quadrant number 1. Because the quadrants don't change. It's just the ends might change and where they actually land might be different. So this one is actually going from quadrant 4 to quadrant 1. Okay, so that is changing it because it's a positive in front of log base 8 versus the previous question, there was a negative sign. Okay, so that's the first 10 marks right there. Let me know in the chat if you guys have any questions about that before I go on to question number 2. Okay, so all you're doing is sketching it, answering domain, range, coordinates of the intercept, and the end behavior. So the only thing that should be adjusted for each of them is the graph and the end behavior. So as a hint to you guys. So how are you guys doing? Are we good to go along? Continue, guys? Alicia's saying good. Brianna, Jared. How are you guys doing? Good? Perfect. Jared, are you still alive? You're okay? Okay, we'll continue. Okay, question number 2, guys. So question number 2 just wants you to change forms. It wants you to go from exponential to logarithmic form. So I've only given one example because if you can do one example, it's pretty much the same for all the other ones as well. So what you want to use is this right here. So I'm going to write it out for you. Y equals a to the power of y becomes log base y. Oh, sorry, it should be base a. Oh, that should be an x. There you go. A to the power of x. So y equals a to the power of x is the same as saying log base a of y, and that should equal x. So this is how you change an exponential to a logarithm. So as long as you remember this, it will make it easier. Or, well, just refer to it. You don't have to remember it. So what you want to do is below each of these, the answer should always be what your y is equal to. This number here is your base, and that should be labeled with the letter A. So I'm going to zoom in so you guys can see that. This guy right here should be labeled as X. So what you're going to do is write it in this form where we have, you guys look over here, I said it has to be log base A of Y. Log base A, which is a little 9, so that corresponds to what I have in my A spot. So that's number 9. And then you put your answer in brackets, which is X, and that should equal Y. Okay, so you want to use the letters that they have over there. You want to use the same letters that they're giving you in the actual question. Okay, so that's what I did. All I did was I looked at what was in my A spot. There is my exponent, and there's my answer. So it's base, in brackets should always be your answer, and then this should be your power. Okay, so I'll just show you one more example. Let's say you had numbers. 8 equals 4 to the power of 2. I should actually fix that so it makes sense, but let's do that, okay? So to change this to log form, it would be log base 4 of your answer, which is 16, and that would be equal to your power, which is 2. So it's just about changing one form to another form using this kind of like legend. So this is a legend that we're using to do that, okay? So if you remember, log of your base in brackets of your answer equals your power, okay? So that's what you have to do for question 2A and B, is just change them to the log form of it, nothing else. You don't have to solve them. You don't have to do anything else. Just change them so they are in logarithmic form. And then question, the next part of 2, which is A, B, it should be actually labeled as question 3, but it's fine. The next part is just going from a logarithmic function to an exponential function. So just going backwards, okay? So now you're going from log a y equals x to y equals a to the power of x. So you can label it if you want to. So I know that the answer is always going to be my x value. Then there's log. This is my base, which is a. And this x right here will be labeled as y. Okay, so we need to write it as y equals a to the power of x. So my y value is actually x. If you guys look, that's x, which is equal to my base. So that's 20. So that's my a value. And what I labeled as red x should be actually to the power of y. Done. That's all you had to do. Okay, so I'll say it out to you guys so you guys can see what I'm saying. So when you have y equals log base 5 of 8, you are writing your base, which is 5, to the power of your answer now. So that's your power, right? So this is your power, if you guys remember. This was your power. And this is going to be the answer in exponential form. So base is 5 to the power of y equals 8. That's all you have to do, is change it to the other form. Okay, use this legend to help you see where the items go. Okay, so give me a thumbs up if you are okay with that, or do you need more examples for that one? Oh, just a little hint for you guys. What do you guys think the base is here if you don't see it? What's the base if you don't see it? That's my question to you. Because you have to include the base somewhere. So in question A, for the logarithmic one, close. It's not 1. I know it's like automatically assumed, but it's actually 10. So if you don't see a base, when it comes to logs, it's actually 10. So that's a little hint to you guys. Okay, so base is 10 if you don't see it. Okay, so keep that in mind when you're changing that question that into the logarithmic or exponential form. If you don't see the base in the log form, it is a 10. Okay, so that's question 2 for you guys. So that's 4 marks right there. Question number 3. So they're giving you the equation in your actual notes that all you have to do is put the numbers in the right spots and then solve for the missing element. So in this case, when they give you this number right here, and they're even telling you that it's concentration, this is your H plus number. Okay, so what you're going to do is put pH is equal to negative log, and then in brackets, you're going to put 8.43 times 10 to the power of negative 8 in brackets. Okay. So whenever they give you moles per liter, that is concentration. So you are replacing your H plus with that value. Then you're going to go to your calculator and put that in exactly how you see it. There's no base, so you can use the button that's directly on your calculator where it says LOG. So if you guys look at your calculator, it's just this one right here, LOG. You can use that one when the base is not given. Okay. So I'm going to write that into my calculator as well. So you're just calculating it. So put that into your calculator exactly how you see it. Another thing you guys need to know is where to find your 10 to the power of it. In your example, you don't have that, but in this example, you do. Let me just go to my calculator and show you that. Okay, so go to your calculator. And you're putting negative sign, log, so that's the button right above LN. So that's like the 4th button on your left from the bottom. And then in brackets, you're putting whatever your moles are. So you guys have a nice number where you don't have scientific notation. Yours is like 0.008, but mine is 8.43. And then I'm pressing shift log. Shift log gives you 10 to the power of, so I'm going to have to actually put multiplication in there. So I'm going to have to multiply by 10 to the power of, in brackets, or in that power spot, negative 8. So that's how I put that into the calculator, and I get this value right there. Okay, so 7.07. This is your pH. Now, pH numbers are only going to go from 0 to 14. So if you get like a negative number, then something's off. Something's not right if you're getting like a weird number. Hey, Seitu, thanks for joining us. Okay, so make sure that you're getting a number between 0 and 14. That tells you you're on the right track. So my pH would be about, to the nearest tenth, 7.1. Okay. So just to let you know how I put that number in, I did negative log, and then I did 8.43 multiplied by, I pressed, on my calculator, I pressed second log just to get that power button, and then I put in brackets negative 8. I put that in the power spot. Okay, so then I put this in the power spot. I closed my brackets and I got 7.1 once I rounded it, so it's the approximate value. So that's my pH for the first question. Okay, you guys just have to put negative log of your concentration, and you don't have to worry about that scientific notation, which is good. The next question, you're using the same equation for question B. But for this question, your pH, they're giving it to you. So they're giving you 6.5. So that's what you're going to put on the left side of the equation. Your next step is to get this negative to the other side of the equation. By moving it over, it becomes negative 6.5. Okay, so drag that negative over, or you can divide by -1. It gives you the same kind of answer. Okay. And then this is where you change it to exponential form. So like I said in the previous question, whenever you do not see a base, it's 10. So when you don't see that little number, it's actually 10. So I'm going to write that in to make it easier. So you always, when you're writing it in exponential form, you write this number, which is your base, to the power of your answer equals h plus. So that's how I convert it into power form. So I'm solving for the hydrogen concentration in moles per liter. And then all I have to do is put this into your calculator. And that would be your final answer. So you're going 10 to the power of negative 6.5. And you should get something like, let me go back, 3 point, it says to the nearest 10th as well, so 3.2. And then whenever you see this value of E, so I just want to show you that this is what it really shows you in the calculator, and I'll show you how to write that in. There's all these numbers here. This is what mine shows. What that means is you're going to write multiply by 10, that's what the E stands for, to the power of -7. So this right here just means 10 to the power of -7. Okay, and all I'm doing is I'm rounding this number to the nearest 10th. So that's why I got 3.2. E, -7 just means 10 to the power of -7. And then don't forget to include the units, which are moles per liter. So that's your concentration of hydrogen ions. So that is for 3 marks, and that answers questions A and B. So question A, find the pH. There's no units when it comes to pH. And for B, you are finding the concentration. So you're just going one way and then backwards. Guys, are there any questions with number 2 or 3? So say 2 if you just joined us. I am recording this, thankfully, because Brianna reminded me. So I'm recording this so you can just later on rewatch the parts that you missed, okay? Any questions with number 2 and 3, guys? Are we okay so far? Go to the chat, give me a thumbs up. Perfect. Okay. Question number 4, you guys have a matching one. So you just have to match which expanded form matches the simplified form. So I'm just going to go over like the general rules, and I'm going to do these 2 examples, and then that should help you to match which one represents the expanded to simplified form. Okay, so for the rules, what you want to remember is when you're trying to go from expanded form to simplified form, any coefficient in front, you want to bring it up into the power spot. Okay, so since this 1/2 is in front of log base 3 of 36, you're going to bring that 1/2 up, and it's going to now belong to the 36. So it's going to look like this. This is called the power law. So the power law states that any number, any coefficient in front can be brought up to the power spot of a log. So we have base 3, 36, those don't change, but now you're going to take 36 and that goes to the power of 1/2. So that 1/2 power only affects the 36, nothing else. And then this guy doesn't have a coefficient. You can leave the negative as it is, but there's no number in front, so you don't have to do anything there. Okay, so I'm going to do the same thing for B as well. So for B, when you see a number in front of the coefficient, bring it up to the power spot. So log of x to the power of 2 plus log of y to the power of 2. Okay, so those 2's in front became powers. I'm just seeing, yeah, okay. And then your next step is whenever you have subtraction between 2 logs, that is called your quotient law. which means that two logs, as long as they have the same basis, will become one single log. So these two guys became one. So that's how you simplify it. And then what you do is you take the first number in front of the subtraction, you write it out, and then you're going to divide it by the number that comes after the subtraction. So that's going to be divided by 2. Okay. So that's actually going to simplify even further. Now, these are numbers, so you can actually work with them a little further. But since you guys have letters in yours, you don't have to go further, right? So there's not much you can do. So 36 to the power of 1/2 is actually equal to 6. So I'm just putting that into my calculator. That just means the same thing as square rooting 36. And then you're dividing that answer by 2. So it became log base 3. 6 divided by 2 is 3. So this would be my final answer because it's still in log form. Now I could actually evaluate this, but for you guys, it's just about writing it in simpler form, not evaluating. Okay, so this would be my answer. So if there's a number in front, bring it to the power. If you see subtraction, write a single logarithm that represents the 2. So one logarithm represents these two guys. And then you're just taking this number and dividing them by that number. Okay, so what it is log of A minus log of B becomes log of A over B. That's kind of like what it looks like with letters. Okay, so this comes from your formula sheet. This is directly on your formula sheet. Now, the next example, I'll just continue that on. So when you see an addition sign, that is called your product law. That means you're going to write these two logs as a single log. Okay, so 2 logs became 1. And then you're taking x squared and y squared, and you're actually going to multiply them. Okay, so when you multiply variables, you don't have to include the dot. So in your simplified versions, it's going to look like something like this. That's it. Okay. And that would be your final answer. Okay, so this is it. I would just stop there. You could actually bring the 2's out, but it's not going to really help you for your assignment, so you can stop right there. Okay, so there's 3 laws. Quotient law, whenever you see subtraction, it becomes division of those 2 numbers after the logs. When you see addition, that's your product law. That means you multiply the numbers or the variables that come after your logs. And then the power law is that number, that coefficient in front just goes to the power spot. Okay, so that would help you with like question 4C. Okay, there's that variable, which they're giving you letter C in front. So that might help you figure out which one matches to that. Just seeing if I missed anything else. Oh, one more rule, guys. One more thing that I want to show you that will help you for that part. Let's say you have log of, let's see, 5 and 8, okay? Log 5 and 8, you can rewrite it to look like this. Log 8 over log 5. So this is called the change of base equation, where you take log of this number and divide it by log of this number, and it's still equivalent. Okay, so those are equal, and you can have whatever you want. You can have the base being 10, you can have the base being anything as long as they're the same. You can have the base being 2 and it still is equal. Okay, so that's one of the other things I want to show you that will help you with one of the questions. So whenever you have log of base 5 of 8, or you could have log base C of 10, that would be the same as saying log 10 divided by log of C. Okay, and then the base could be anything you want. It could be the variable Z, it could be letter Z, it could be a 5, it can be a 0.2, as long as they're the same at the top and bottom. Okay, so that's what I want to show you. Okay, so that's it for question number 4. There's only one more question left. Okay, so this one's similar to question number 5. It wants you to solve it algebraically, and it does want you in your assignment to round to the nearest hundredth. Okay, so this is how you solve algebraically. Step 1, put a log on both sides of the equation. Okay, so I put log on both sides. What you do to one side, do to the other. Next, you're using the power law, but in the opposite direction. These powers are going to move in front. So I'm going to put them in brackets. X minus 1, which was the power, now becomes a coefficient. So it goes in front of log 2. And the same thing on the right side. In brackets, x plus 1, close your bracket, goes in front of log 3. Okay, so power goes down to the front. Next step, you're going to distribute this log 2 into the brackets to both terms. Same thing here. Log 3 goes to the x, goes to the positive 1. So that's going to look like this. X multiplied by log 2, and then minus 1 multiplied by log 2. So that's the left side of your equation. When you multiply x plus 1 with log 3, it becomes x multiplied by log 3, and then positive 1 multiplied by log 3. So I've just distributed the log 2 into the brackets with what was in the brackets going in front. Your next step is to get x's on left side and non-x's on the right side. So what I'm doing is I'm keeping this x log 2 that was on the left side as it is, but I'm going to bring this to the left side as well, but that changes its sign. So it used to be negative, or it used to be positive x log 3, but when I move it over to the left side of the equation, it becomes negative x log 3, and then I put the equal sign. This is going to go to the right side because it doesn't have the variable x. So what you're doing is you're switching their sides. Those guys are going to switch sides, but when you do that, you have to switch the sign as well. So negative 1 log 2 becomes positive 1 log 2 when you move it over to the right side. And positive 1 log 3 doesn't change positions because it was always on the right side. Okay, so just these guys changed signs if you guys look at it. Underlined, changed signs. Once you have the x's on one side and the non-x's on the other side, you're going to factor x out. And what that looks like is you're going to take x out, and then that goes in front of brackets. And then everything else stays the same. So I remove the x from the x log 2, and it just becomes log 2. I remove the x from x log 3, and it becomes minus x log, or minus just log 3. So that's the left side of your equation now, once you take away this guy and put it in front of the brackets. So that's factoring. On the right side, don't change anything. Our second last step, guys, is you're going to divide both sides by what was with the x, because you're trying to isolate for x. So you're going to move this to the right side of the equation by division. What you do to one side, do to the other. These guys all cross off. So these guys all cross each other off, leaving us with x equals. Now to do this properly, you're going to first calculate the top and put that into your calculator. Then in a second step, you're going to calculate these two answers. And then in a third step, you're going to divide the two answers you get. So you're less likely to have issues or errors if you do that. I find when people try to do it in one step, that's where they lose marks because they make a calculation error because they forget brackets. And so that would change your answer right there. So you got to be really, really careful with that. So I'm going to just show you what I'm putting in my calculator and how I do that. And then we're good to go, I think, I hope. So in my calculator, I'm doing the top separately. So I'm going 1 log 2. I don't know why I did double bracket there. Okay. 1 log 2 plus 1 log 3. That's the top of my equation, equal. So that's the top answer. The bottom, the denominator was log 2 subtract log 3. Press enter. Now you have two solutions. All you have to do is now take those solutions. So I can even, in your calculator, you could highlight that and then divide it by highlighting the one above. So as you can see, I'm taking the answer from the top and dividing it by the answer at the bottom. And I should get this negative 4.42 if I round to the nearest hundredth. Hundredth means 2 decimal places. So negative 4.42 is the solution I get from doing that. Negative. Done. Okay, so that's it. So this way I know that there's going to be less errors because if I try to do it all in one step, usually I found that like I would say half of the people get it right and half the people get it wrong just by putting in their calculator because there's just too many brackets there. So if you do that, I would say that it'll solve a lot of your issues. Okay, so that is your assignment, guys. Let me know if you guys stick on here, if you still have questions from your previous assignment, or if you have or you need more kind of examples for this one. So I'm going to stop recording right now. But if you do have any other questions, let me know right now in chat.